All right, so hopefully that activity helped you remember the transformation rules, but I put them down here in writing if you need them. So the negative in front of the parentheses helps us have that reflection over the x-axis. So if you remember when you graphed quadratics, normally they're U-shaped, but if there was a negative out in front, it just flipped upside down basically. So if you think about the x-axis, it just literally flipped right over that thing, a reflection. The A in front either causes the stretch or the compression, depending on if it's a fraction or not. And then we have our horizontal transformations, so inside with the x, because x runs horizontally. So don't forget that opposites, because we're setting it equal to 0 inside that parentheses. So positive will go left, negative will go right. But vertical, you notice the K follows the intuitive symbol there, so up will go down. Sorry, up will be positive, down will be negative. All right, so I tried a few of these examples real quick, so let's talk about them. You're going to start out with x cubed. So if we have a vertical stretch by a factor of 2, I'm just multiplying 2 at the front of the parentheses, the coefficient there. A vertical translation, so vertical's up and down, that's why it's plus 4 at the end. And then a horizontal translation left 3 would be positive 3 in the parentheses with the x. And then notice B. All right, and then looking at a few graphs real quick. So I just used the transformation rules. So remember the parent function starts at 0, 0. So I went left 2, down 1. And then I like to plug in points personally. You can use the rules of, they're not necessarily rules, but you can look at the parent function, and because there's no stretch, you know it'll move at the same rate, so you can kind of look at those points. But anyways, I start at -2, -1, right? So that was basically vertex form. It's not the vertex, actually, it's a critical point. But -2, -1, I get that from the transformation rules. And so then I just plugged in a -1 in there, which gave me 1 cubed, minus 1 gave me 0, and I plotted that point, and then basically did the exact same but in the opposite direction to go to -3, -2. Then I plugged in a 0, which gave me 2 cubed, which is 8, 8 minus 1 is 7. So then I just kind of reflected that. So if I go over 2, up 7, I went over 2, down 7, which actually took me off the graph. Kind of. It took me right to -8. All right. This next one, again, I just used the transformation rules. So I noticed that I would start at 0, 1. And then I plugged in a 1, which gave me 0, because I got -1 plus 1, which is 0. That again, because I went down 1 over 1, I went up 1 over 1, because I know that cubics are, I know about their behavior, right? So I only do a behavior table for one side, so I can just see that opposite will happen for a cubic. So I just look at the parent function, remember the patterns, and go for it. Okay, then I plugged in a 2, which gave me -8 cubed, plus 1, which gave me -7. And then again, so I went over 2, down 8 from that point, and just took care of that. And kind of same thing over here. As you notice, I started at 2. Oops, wrong thing. I started when x was 2, but y was 0. And again, I just plugged in more points. So 3 minus 2 is 1, 1 cubed is 1, 1 times 1/2 is 1/2, and again, kind of did a reflection there. Then I plugged in a 4, 4 minus 2 is 2, 2 cubed is 8, and then 8 times 1/2 is 4. So at 4, it was at 4, 4, and you can see at 0, it's at -4, so I just reflected that. All right, quick few more examples. So looking at a square root, I looked back at the parent function to remember what that looked like, and then I just made a quick behavior table. So I noticed that I was starting at 0, when not 0, sorry. I noticed I was starting at -3, 0, because I just applied that transformation. The parent function starts at 0, 0. So then I just flipped the sign and knew that I was going to move left 3. So negative 3, 0. And then I plugged in a negative 2, which gave me 1 cubed, which output is 1. And then I kind of remembered that pattern, but I knew that I couldn't get a square root until I made the inside that radical 4, so I thought 3 plus what gives me 4, and so the next point I plugged in was a 1, right? So 1 plus 3 is 4, cube root of 4 is, square root of 4 is 2, so at 1 we're lined up with 2, and then I thought the next number that I can take the square root nicely is 9, so I thought x plus 3 equals 9, x must be 6, plugged it in, 6 plus 3 is 9, square root of 9 is 3. And so you can see I have 6, 9 graphed there. So that's what I did on those. Let's look at this one. So normally we start at 0, 0, but I'm going to go right 1, down 2. All right, and so what I did is noticed I started right there. And I could plug in a 0 just to see what would happen. But remember, 0 minus 1 is negative 1. You don't have a real number when you try to take the square root of a negative. So that's why I never go to the left on these. All right, so then I plugged in a 2. 2 minus 1 is 1. Square root of 1 is 1. 1 minus 2 is negative 1. So at 2, it's at negative 1. And if I try to plug in a 3, it's going to give me a decimal. 4 is going to give me a decimal, but 5 will work. 5 minus 1 is 4. Square root of 4 is 2. 2 minus 2 is 0. So I went over to 1, 2, 3, 4, 5, 0. 6 minus 1 is 5. 7 minus 1 is 6. 8 minus 1 is 7. 9 minus 1 is 8. So then I plugged in a 10, but 6, 7, 8, 9, 10. All right, so 10 minus 1 is 9. Square root of 9 is 3. 3 minus 2 is 1. So at 10, I'm at 1. The graph doesn't go any more to the left because you can't take the square root of a negative. And I'm going to write down my domain on this one. As you can see, we're starting right here on the x-axis at 1. We're going clear out to infinity. And range, we're starting at negative 2 and going clear up to infinity. Let's do the domain and range on this guy. So reading my x-axis, I'm going to start at negative 3 and go to infinity. And range, I'm going to start at 0 and go to infinity. All right. So I hope that helps. If you need more assistance, please let me know. And good luck on the